Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 280, maximum and sum of array. So this one, you should hit the like button and hit the subscribe button and join Discord. That's all I have for this one. No. But this one, it's kind of weird because I think for me, it's just about looking at the constraints, and the constraints will tell you that there are 9 slots. At most, there will be 18 numbers. Nums of I don't think that matters that much. Or at least I didn't use anything to use on it. But maybe it's there so that it throws you off a little bit. But that said, given that n is equal to 18 and you have 9 slots, then this becomes a easy to do brute force with memorization problem. So that's basically what I have here. I'm going to give a 2-minute overview on bitmask. I don't want to spend that much time on this on bitmask in this video because this is a Q4, this is a Leetcode hard. Definitely practice bitmask on easier problems before doing it. And the idea behind bitmask is that, okay, let's say you have a Boolean array, right? So you have true, false, true, false, true, 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 true. I don't know, something like that, right? It doesn't, some Boolean array. So that's basically like a Boolean array, right? And then if you just, change the trues to 1 and 0 to false, then you have this, this is the same this is a different representation of the same Boolean array, right? And then now, the third thing to do is now convert. You see this, you go, okay, I can interpret this as a number. And that's basically the idea behind a bitmask, is a number that uses every bit and a mask to kind of see which bit is true and which bit is false, right? And then there's two things that I do to kind of go about it. One is that you see this thing, the AND thing. So that's basically saying, let's say if I want to see if the 5th digit is good. So I have, I generate this number, or 4th digit, I guess in this case maybe, or 5th, but 4th 0 index digit, right? So basically, this one left shift by I is going to generate a number that looks like this. And then if you do a bitwise AND, then obviously, if this is a 1, then this will give you a non-zero number. And if you, for example, if you shift this to here, if you do an AND on these two, it will give you a 0, meaning that, that this is false. And of course, you can use however representation that you want, and that's basically the idea. The only other place that I do it is this thing. The one left shift by I is the same thing, right? We already talked about it a little bit. It just gives you one bit that's somewhere. And in this case, what we want is that we want the OR of it, so that, and because, we already checked that this is already equal to 0. So this OR basically just flips it from 0 to 1. So when you do the recursion. So that's basically the idea. That's going to be the shortest bitmask tutorial so far, but I'm going to just go over the rest of this problem. So the states for this problem, and you can do the math a bit, but slots can go from, so that's one thing I would say about brute force dynamic programming problem type or memorization in general is, I don't always explain the problem in that way. Always analyze it first, because otherwise it may, otherwise it will give you a sad time. But because you're going to type it out and it's going to give you time limit exceeded. Though one caveat I have here is that you can see that here I took 12 minutes and one wrong answer. The reason why I got that wrong answer is actually Python 3 times out for me. I actually rewrote this in Java. This is exactly the same code, maybe a little obviously more Java-y. But so going over the Python code will give you the same thing. I don't know. This is an explanation video, but I'm probably going to complain a little bit about this because this keeps happening with them. But anyway, slot goes from 0 to 9, 0 to 9. left goes from 0 to 2, and mask goes from 0 to 2 to the 18, right? Minus 1 technically, I guess, because n can be number of slots, and the bit mask on 18 n is 2 to the 18. And of course, if you multiply them together, well, this is just going to be like roughly 2 to the 19. Yeah, and you just calculate together to kind of do the math, right? And yeah, 2 times 9. So yeah, 18 times, was it 250,000, right? So that gives you 4 million times n is going to be probably a little bit slow, but yeah. But apparently it is very fast enough in Java, so maybe, yeah. Cool. But yeah, but otherwise this is just brute force, right? We go from one slide at a time. We keep track of the number of numbers that are left for this current slide, and you know, it could be 2, 1, or 0, as you know. So yeah, and bit mask is just keeping track of all the numbers that we used on nums. And yeah, I think that's pretty much it. And for the input, I'm just thinking maybe, yeah, I don't know. I think maybe I did this the wrong way. Maybe not. Maybe it's fine. I think there may be a minor optimization if instead of the way that I did it here, I could put the nums into the slot one at a time instead of like going through start from 0 to 9 and look and enumerate all the masks. I could look at each number and then enumerate them on the slots, maybe. But that's a little bit awkward, I think, to keep track of what's left. So maybe this is still a little bit better. I don't know. But we can do that analysis, you know, as a homework for the reader at home. So yeah. So basically, now you have you can, for example, you could say, okay, the slide is done no matter what. Either it has no slots left, or we just want to move on to the next slide because, I don't know, you have more numbers and you want to give it to a later slide. Yeah, then we just skip ahead, and this is basically what this represents. Otherwise, if there's if there's a slide in the slide, and you could put a number in it, then we do a for loop to look at every possible number and put a number in it. That's pretty much it. This is pretty straightforward, and that's, yeah. And what's the this is going to be O of n time, obviously. So that means that time is going to be equal to O of s for slots times 3, which obviously will, you know, we'll get rid of bit mask, and then 2 to the n, right? And that's pretty much it. And then of course you get rid of the 3. Oh, and for each that's number of inputs, right? So, and each one will take O of n because of this loop, right? So yeah, and in terms of space, we get just what we said before, s times 3 times 2 to the n, and we get rid of the 3 because it's just a constant. That's pretty much it. It's very brute force, so I mean, I technically didn't even go over this really, but we use one of the slots and then we just add this to the score of the slide, which is what they tell you to do here. So yeah, I mean, because this function is linear, so it's pretty straightforward to do so. Cool. That's all I have for this one. Let me know what you think, and you could watch me solve a live in contest next. I actually, yeah, as you even get a bonus thing of watching me write it in Java. So if that's help, so you're a Java lover, this is a bonus for you. But yeah, you could watch me solve a live in contest next. Okay, that's good. Oh, 5 people finished, so maybe I'm catching up a little bit, not that much. Okay, you're given a... There's only 9 numbers, so this is probably going to be some brute force bit maskings. But okay, let's see. And . and some. Let's have 1 for 1 and 1 plus 3 and 1 plus 4. 6 and 2 is 2. Oh, the slot 2. Okay. So there are 9 slots, 15 numbers. Yeah, I mean, this is just going to be brute force DP thing. So I don't know. Let's see. Slot. Mask. This is actually kind of tight. 9 times 2 to the 18. We'll see if this is fast enough. Maybe that Python is too slow and I'm going to have to be sad again. Okay. Each slot contains at most 2 numbers. That's weird way of phrasing it. But I think this makes it slightly faster. Yeah. Okay, so let's say we skip, right? So pass 0, 0. Go slot plus 1. Left is 2. Then mask, right? So yeah. T for try. Okay, so same slot. Okay, if left is greater than I guess this is already this, but okay, so same slot. If left is greater than 0, then we do this. This is going to time out and I'm going to be really sad. Okay. I think that's pretty much it. Except for that slots from 1 to n, so this is actually slot plus 1. Okay. Let's see if it's fast enough, or maybe if I make a mistake. Come on, it's Python. This is pretty basic. Come on. I mean, they don't care about Python. I mean, that's pretty much it, right? This is so silly. This is, I don't think there's anything I can do differently, really. Like, I feel like we have the same conversations about how to do this in Python every time, because this is n times 2 to the n times whatever. So I mean, it's not fast, but it's not. I actually don't even know how to do this anymore. Is it just like this? I guess that's 105. I hope this is the right syntax, because it's been a while. I hate you for making me do this again. Like, this is just, I don't think I do anything really that weird, so I think I'm just rewriting the code. How do I write this? I don't remember. I have to remember the cache, Larry. We remember the cache, please. Please. Compiler error. Oh, well, that's just me forgetting to write a comma. Okay, still good. I can actually copy paste this. This is actually same code. Okay, let's run it real quick. It might time out. That's fine. Okay, that's fine because I didn't cache. Let's see. Wait, is that right? Is that the syntax? I don't remember the syntax. For multi-dimensional stuff in Java. Okay, still time limited, that's fine. Was it 3? Where is it? Slots? No, masks. So that's 1, 2. Yeah, still no timeout, I forget. Okay, fine. If index 6. Or which one? So that's good. Pretty fast too. Okay, so that's good that is outbound, but why? Tell me why. Do I have a typo somewhere? Do I update any of this? No, I don't think so. Oh. Yikes, 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 yikes. Okay, so this is outbound. Why? Oh my. So 0, 1, 2, 3, 4, 5, 6. Why is it 6? Isn't it not slots? Oh, this is not. No, that should be right. Huh. Oh, I did this and this is not right. This is num slots. Okay, I am dumb. That's right. That's right, Larry. I still have to move this here. Okay, I forgot. Okay, 9, 24, and 51. Almost wish that timed out because that is just silly that I have to eat another wrong answer for this one. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Stay good, stay healthy, to good mental health, and I will see you later. Bye-bye.